This is lesson 8.4, part 2. We are going to multiply rational expressions. We're going to use the same 3 rules that we used when we simplified expressions. The first thing is to factor the numerator and the denominator. When you factor, we want to write it as a single fraction. Then state your restrictions, and then simplify. Let's give it a try. Letter A. Step number 1, factor. I've got my numerator, x plus 3. There's nothing I can factor out of it. The x squared minus x minus 6, it's a trinomial, and I can factor. My lead term is a 1, so I'm going to go 1 times negative 6. What multiplies to give me negative 6 and adds to give me negative 1? I'm going to do negative 3 times 2. Negative 3 plus 2 gives me my negative 1. So this trinomial factors into x minus 3 times x plus 2. Going to my denominator, x squared minus 4. There's no GCF. It's a binomial. And I notice that I can take the square root of each term. This is the difference of 2 squares. So I'm going to do x minus the square root of 4, which is 2, and x plus the square root of 4, so x plus 2. And in my last one, the trinomial, my lead term is a 1, so I go 1 times the 9 is just 9. What multiplies to give me 9 and adds to give me 6? Let's do 3 times 3. And 3 plus 3 is 6. So this trinomial factors into x plus 3 times x plus 3. So let's rewrite this all as a single fraction. Here, everything is written as my single fraction. All my numerators and my denominators. Step number 2 was to state my restrictions. That's what cannot be in the denominator, what x cannot equal. If I set the first term equal to 0, I see that x can't be 2. The second term shows me that x can't be a negative 2. The third term, x cannot be a negative 3. And the last one, it's also negative 3. I only have to write it once. So my restrictions are 2, negative 2, negative 3. We took each group of parentheses, set them equal to 0, and solved. Then in my last step, I can simplify. I have x plus 3 in both numerator and denominator, and I have x plus 2. Cancel those out. My final answer is x minus 3 over x minus 2 times x plus 3, where x cannot equal negative 3, negative 2, and 2. So it's very similar to when we simplified. We're just going to have 2 different fractions to work with. All right, take a look at letter B. Since we factored several of them together now, I want you to try one. Try letter B, push pause while you do your work, and then resume play to check your answer. This is my work going through the problem. X minus 7 could not be factored. X squared minus 1 was a difference of squares. I could square root both of them and get whole numbers. So that was x plus 1 times x minus 1. The x minus 1 could not be factored. And then I noticed there was a GCF on this binomial of 3. So I divided the 3 where I factored the 3 out, leaving me with x minus 7. I put them all together and stated my restrictions. If x minus 1 was equal to 0, and I solved, I got that x could not be the 1, and x minus 7 cannot be 0. Add the 7 over, and I got that x could not be 7. Then I came back and reduced. X minus 1 was in both. X minus 7 was in numerator, denominator, leaving me with x plus 1 over 3, where x cannot be a 1 or a 7. Did not have to worry about the 3 in my restrictions because there's no variable attached to it. If you have a number, a GCF that you factor out, and there's no x, it just stays in the problem. All right, let's take a look at letter C. I wanted to do one of these where there was no plus or minus. This is all one term. There's no factoring involved. We can skip right away into writing them as one fraction. Sometimes it's nice or easier to visualize if you bring your numbers together and then your variables. And in the denominator, I can bring my 8 and 12 together. I'm going to put x to the 4th under the x squared, and then my y's under each other. When I go to state my restrictions, 8 times 12, x to the 4th y, cannot be 0. There's no plus or minus. Everything here is being multiplied. What that tells me is that both the x and the y cannot be 0. Anything times 0 is 0. So if there's no plus or minuses involved in the term, your variables cannot equal 0. Now I'm going to come back and reduce. The 4 goes into 8, leaving me with 2. X squared cancels with x to the 4th, leaving me with x squared, and the y's cancel. So my answer here would be 7. Nothing else in the numerator. 2 times 12, which is 24, x squared, where x cannot be 0 and y cannot be 0. And that ends part 2, multiplying rational expressions. And in part 3, we're going to do division.